This is going to be a beginner's guide to using the CAM component of Fusion 360. This is for somebody who has never used the CAM tools before, and I'm going to show you how to get up and running quickly so you can run your first parts and start learning without getting too into the weeds on all the available tool paths and features. We do a fair amount of milling with a typical 3-axis CNC, so I'm going to share my experiences as they apply to a novice and hobby type user. I picked this part because it has some interesting and common surface features that may seem overwhelming at first, or even impossible without extensive tool changes, but I assure you that is not the case. You could make this with as little as one end mill if you really wanted to, and if you're just getting started, that's probably sufficient to start learning. So we're going to navigate to the Manufacture tab in the top left-hand corner here. We're going to go Manufacture, and we're going to see all the toolbars up here change to our various tool paths. We're not going to get too much into the toolpath options today. I'm just going to show you some quick ones to get started. First things first, we're going to click this file folder up here under the Milling tab, and that's going to bring up our setup window. So this is where we're going to tell the software all the critical information it needs to know before it can start generating toolpaths, and that's going to be what we're making it from, and where our 0 point's going to be. What it's done here is it's superimposed a piece of stock on top of our piece, and it's plopped our 0 on top and in the middle, and these are probably just the defaults for the software. It might be different for different users, but that's the way it popped up here. The stock, as it's projected, is just slightly bigger than the piece. And if we want to make any changes to that, which is exactly where we're going to start, we're going to go to the stock tab here. We're going to click that. And we're going to talk about two different stock options we're going to look at for this piece. The first one is what it defaults to. It's called relative sized box under the mode here. And what it's using to calculate the stock size there is the size of the piece, and then it's adding these modifiers to the sides and the top to determine a stock dimension, which it's displaying down here. So these can be adjusted, and we can add a little bit more or even a little bit less if we were crazy. But ultimately, what all it is a mathematical equation between the size of the part plus these modifiers onto a rectilinear prism, and that's how it's going to determine our stock size. That would work well if you're looking to make a piece of stock and you're trying to be efficient with your material usage. You might want to just add those modifiers and then produce a piece of stock to these dimensions. Typically, I use the second option we're going to talk about, which is the fixed size box right at the top here. This is where you tell it what the stock dimensions you're working with are, and then it will put the piece inside that. We like this one because you can enter in what the stock sizes are. I'm not confident enough to produce stock sometimes to 1/10 of a millimeter, as a relative sized application might require you to. So with this is a little bit easier for us. We can produce it to a millimeter. We can have standard block sizes that we use for a couple different parts, and we don't have to worry about it. You can enter in your X, Y, and Z heights all here, and it will tell you down here, it's just telling you what your model dimensions are, just so you're aware. Basically, all that's for is if you enter in any one of these numbers that is less than your model dimension, it's going to highlight the text red. It's going to let you know that there's a conflict there, basically because I put the X width for my stock at 150 when the model width on the X is 154. It recognizes that there's an issue there, and it's going to leave some of the part behind. So that's a handy little feature if you see red anywhere, and it'll give you warnings when you try and generate this that there is a problem. The other thing we'll see here in our options menu are the model position. As you can see, it kind of just centers it in the stock, it centers it laterally, it centers it in the vertical. We might want to change this depending on how we're fixturing the part or what we want to come off the machine. We might want it this face down here if I face milled the underside of my stock, in which case I would go to the model position under the Z height here. I would go model position, offset from Z bottom, and then what it's going to do is it's going to leave my piece right where it is, but it's compensated with this offset. So if I want it right on the bottom, I'm going to change that to 0, and it's going to move it right to the bottom. So I might want to do that if basically the part I want to come off the machine is going to be finished dimensions. Alternatively, if I was going to be fixturing and I had some vice jaws down here or something like that, I might want the piece sitting up at the top, and I'll face mill the rest of it off the back side later. I'm going to set that back down to offset from bottom Z. I'm going to leave it there, and I'm going to move on. So the next thing in our setup, we're going to go back to the setup tab here now that we're happy with our stock size and position around the model. The next thing we're going to do is determine our 0 point. It has defaulted the 0 point right here on the top in the middle, but that might not work very good for you. It's going to be kind of hard to zero off that point. So what you can do, as long as the origin drop down over here is set to stock box point, we can select any of the points around the stock. So that's the corners and various center points all around the stock. We can click any one of them and we can use that as our origin point. Typically for us, we like a back corner. It's easy to zero the center axis of the tool in with that corner, and then we can just touch the end of the tool down to the top and we can get our Z zeroed correctly. If you're working off a machine bed zero, you might want to be down here. For us, we're going to work here and we're going to move on. We're done with the setup window. Without getting into too much more of it, we're just going to click OK. So now that we've done that, we have a setup listed here under our setup drop down on the left hand side. And underneath this is where we're going to start making all of our tool paths. But before we can do that, we're going to make some tools. So if you haven't done this already, you're going to go to your tool library. That's right up here in the middle. You're going to click that. And this window is going to pop up. You might see a bunch of tools here, or it might just be blank and look something like this. Either way, the first thing I'm going to recommend is you're going to go to your local drop down here. You're going to right click it and go New Library. We're going to make a library for our tools, and the reason we do that is because typically you're using the same tools over and over again, and we're going to adjust these tools specifically for our machines and the kind of applications we use them for, so we don't want to just be running generic tools. So after I've made that library, I have two options. I can go up here, I can click this plus sign up here, and I can build a tool. My recommendation is don't go that way. Go down to the Fusion 360 library on the left hand side here. We're going to go to milling tools and inch, and it's going to bring up a whole library of tools that already exist, and this is going to make building our library a lot easier. So if I'm looking for a specific tool, I want to use a 1/4 inch flat end mill, for example. I'm going to click that tool, and you're going to see it has all this preset information built into it. For various operations, feeds and speeds. Those are just going to be generic values. Most likely they're not going to work with your machine, but it gives you a starting point. So if this is the tool I want to use, this is one that's in my inventory, I'm going to right click it. I'm going to go copy tool. Then I'm going to go back to my library. I'm going to right click in the window there, and I'm going to paste that tool right into my personal library. So then it's going to pop up. And now we have a tool in our library that we can use to start making cuts. You can go into these tools, you can right click on it, and you can edit it. I'm not going to go into any of that today. I will do separate videos on building tool libraries. For this video, I'm going to assume that this tool is going to work for us or is close enough to the tool that we're actually going to use. I'm just going to get you back to generating some tool paths. So we're going to close this window, and I'm going to show you the 3 tool paths that we use more than any other ones, and that starts with this one. It is right here, adaptive clearing. It's a 3D adaptive clearing strategy. This works great for roughing out your material. We use it all the time, so we're going to start by clicking that one. And then this window is going to pop up on the right hand side, and we're going to start at the very top under tool, and we're going to select our tool. So fortunately we have a library and we have our newly added little tool right here, so we're going to click that, select. And when that tool loads up, we're going to notice 2 things. We have our tool representation up here in our environment. And over here under the feeds and speeds, that tool brought in all kinds of data. The benefit of pulling the tool out of the Fusion 360 library is it's going to come with a bunch of presets for different cutting operations in different materials. These may or may not work for you, but they're a starting point. So if I was doing some aluminum work, I might click the aluminum slotting, roughing, finishing. I'll do roughing. And it's going to preload all these parameters, your spindle speeds, your feed rates. It's going to calculate your feed per tooth, all that kind of information. The 2 main entries we're concerned with are spindle speed and cutting feed rate. We can change any of these values, but if you're new to CNC machining, these are going to be the 2 you're going to focus on, your spindle speed and your cutting feed rate. As you get more advanced, you can play around with some of these other parameters and figure out what works better for you. And you can enter in any value you want here, and that is the value it's going to use when it's generating the code. So we don't have to go and change any of our presets. The second we change a value in any one of these boxes, it's just going to change the preset to a custom, and it is only going to be applied to this cutting operation. It's not going to save that data. If you want to save that information into your presets, you can do that through the tool libraries, which I will explain in another video. I'm happy with my feeds and speeds, so I'm going to move on to the next tab. Under this tab, I'm only going to talk about the geometry, and that is the machining boundary. This orange line here is showing you the boundary of the cutting operation, and we have a couple of options with that in mind. So it's currently defaulting to no machining boundary, which means that the tool is free to enter and leave the sides of the stock as it pleases. If I don't like that, I might change it to a bounding box, and then I get some options for tool containment. So my options are tool inside boundary, tool center on boundary, and tool outside boundary. So for example, if I wanted to contain my cutting operations within the exterior perimeter of the stock, I might want to do that if it's being fixtured externally on those edges and I don't want to collide my tool with the fixturing. I can select tool inside boundary and it will contain all that cutting within that boundary. And I can even set an offset so that it leaves a certain amount of margin around the perimeter as it's doing that. If I don't want a boundary, I just change that to none. That's where I'm going to leave it. I'm going to let the tool do what it wants. I'm going to move on to the next tab, which is going to be all our heights. So here it's displaying 4 different heights. We have a clearance height, a retract height, a top height, and a bottom height. So it's inserted these planes into my environment here, and it's representing the various heights the tool is going to ascend and descend from during the cutting operations. So the clearance height is where it's going to start its cutting operation and retract to when it finishes all the cuts. The retract height is the height it's going to use in between the various moves. And then we have the top height and the bottom height. So our top height and bottom height just default to stock top and stock bottom. If I wanted to change that, for example, I don't want it to mill all the way through the stock on the bottom, I can change the value of the bottom height and bring that plane up so it will leave some material behind. These other heights might be adjusted if you have limitations on your Z travel, or for some reason, maybe to clear some fixturing or something else you got going on, you might want to bring those up, especially the clearance height, so it doesn't crash into something as the machine is returning to 0. If I'm happy with these numbers, I can change any one of them, but they look good to me. I'm going to move on to the next tab. So the key pieces of information housed under this tab are your step over and step down. So as it's running an adaptive pass, it's going to do 2 things. It's going to step over to clear material in between its passes, and it's going to step down through the layers. So the first bit of information we're going to look at is the optimal load. So that is your step over, and that is how much the tool is going to move radially in between passes. So this number is going to depend heavily on your machine, the material you're cutting, and what you're trying to produce, and it's something you're going to have to play around with. These are the values that came in with those presets on the tool. So this one I might not quite like. I might just change that to 1. And then moving down, we get to our maximum roughing step down and our fine step down. So these are the Z-axis move. So because it's going to cut in layers, this is how much it's going to cut off in between each layer. So your roughing step down is that big bite right at the beginning, and then the fine step down is just increasing the resolution of the roughing cut, leaving a little bit less material to clean up afterwards. So these numbers, they can be whatever you want. I'm going to pick 8. So as you can see, it's auto-populated my fine step down with a value that is 1/10 my maximum roughing step down. That number doesn't have to be 1/10, that's just a value it seems to use. It could be half, it could even be the same if you don't want those fine step downs. Either way, it should be a number that fits into your maximum roughing step down value, whether it's a 1/10 or a 1/4 or a half. But if those numbers aren't divisible, it will make some tool pass. It'll just make for some messy code. So I'm going to change this. I don't typically use fines on that low of resolution, so I might just go 4. And then the last box we're going to look at is the stock to leave. So this is how much it's going to leave behind in this roughing pass to be cleaned up in subsequent passes. So we have our radial stock to leave and axial stock to leave. So that's going to be everything it leaves on the sides of this part and everything it leaves on the top. So those values are independently adjustable. You can do with them as you will. I'm going to leave them alone and move on. So I'm done with everything under the adaptive milling strategy, and I'm going to click OK. So you can see that it is currently generating the tool path over the corner here. We have our first path underneath our setup, and it's actively generating the code and the tool paths that it will be using. So what we're looking at is the blue lines represent the center path of the tool. So those are all the cutting operations. The yellow lines represent travels in between cuts, and these red lines represent the path of entry the tool is using to make a cut. So in these boreholes here, it's using a circular ramp path, so that's what you're seeing there. We can right click on the tool path and go to simulate, and we can actually watch this process unfold. So on the right hand side here under simulate, you'll see a box for stock down here. Make sure that's clicked, and it's going to show you what your stock's going to look like before the piece is made. And then down here in the middle I have this play button, so I can click that. I can speed it up with this dial down here, and I can actually watch my cut take place. So we can see how this adaptive pass is going to work to mill out the piece. And you can see those blue lines and yellow lines and red lines in action. So that's a nice little feature there. And this is where it's actually going to show you if you have any crashes in your toolpath data. So it's important to run these simulations and just make sure everything looks okay. We're done with this. So we're going to click exit simulation down in the corner here. And we're going to move on to our next toolpath that we're going to run. So under the 2D tab here, we're going to go down to our 2D contour, and we're going to click that. So same as before, it's going to ask us for a tool. It's defaulting to the previous tool used, which is the tool we're going to use, so we're just going to leave it. Same as before, you got all your different feeds and speeds down here if you want to make any changes for this cut path. So we're going to move on to our next tab. And this is going to be a little bit different than the last one. So this is where you're going to select the geometry that you want the cut to follow. So for example, if I wanted to mill the outside perimeter, or I wanted to mill some of these inside shapes or boreholes, what I have to do, so long as this box up here is selected and it's blue, I can start picking the geometries that I want it to contour. So from the underside of the part, I want to pick these full lines. So if I wanted to do my outside, I'm going to click that. I might also want it to do this guy and this as well. And then if I wanted to clean up some of these upper counter bores, I would click the bottom of the upper counter bore, and then it will do those as well. I don't necessarily want it going down into these holes. My 1/4" tool might not fit down there or have the tolerances it needs to make the cut, so I'm going to leave those alone. But now that I've selected all these geometries for my tool path, and they're all going to be listed here, I'm going to move on to the next tab. So the next tab over is going to be your heights tab. Now this is the same as before. You just got your clearance, retract, and feed heights. You'll see these with all of your tool paths. You can adjust them if you need to. We're going to leave them alone. We're going to move on to the next tab. And this is where we're going to enter all the specific parameters on how we perform this cut. So a couple things to pay attention to here are going to be your sideways compensation. And this is going to be what side of the tool it runs down the face. Basically your climb or conventional milling strategies. You have your feed rates, and you can also select multiple finishing passes. So you could do this if you left more than 1 millimeter all the way around this piece in your previous pass. You might want it to run those contours in steps to whittle down the material before it does its final finish pass. So in here we also have our finishing overlap. So this is going to be how far the tool is going to move past the starting point after it has completed the perimeter of the cut. So this is a handy way to clean up those start marks, and whatever distance you enter here is how far it's going to go past the starting point while following the perimeter, and then it's going to exit the cut laterally and leave a nice edge. So that's something that we use quite a bit. Additionally, you have multiple depths and stock to leave. So stock to leave we're familiar with. If this box was checked, we could have this operation leave a bit of material as well. If we want it to be a finishing pass, we don't want anything left behind, we want finished dimensions, we're going to leave that unchecked. The other thing is the multiple depths. Like the adaptive pass, we can set the number of times the Z-axis steps down while performing this cut. It's fully adjustable. It doesn't have to do it in one big move, so you can adjust all those parameters in here. This, for us, we're only taking off 1 millimeter, and this is not surpassing the flute length of our tool, so we don't need to worry about it. I'm going to leave that unchecked, and I'm done with everything in the 2D contour. So I'm going to click OK. And as before, it's going to generate those tool paths. You can see these blue lines going around the side. They've been compensated for the diameter of the tool. We have 2 down here, and that is because we are running 2 finishing passes. So I'm just going to run a quick simulation to show you what this tool path is doing in case it's unclear. So as you can see, it's going to all my selections and it's just following those perimeters, and it's going to clean up all those edges and take away any of the nonsense left behind by those adaptive passes. This is a great way to get an excellent edge finish on all your pieces. And because we've incorporated 2 final step overs for the finish, we can really dial back that last pass and get it as nice and clean as possible. So now we are done with this operation. We're going to move on to our next one. So you can see here that our part doesn't look quite right. Some of these inner depressions have all these sort of sharp edges going up. That's from the 2D adaptive pass. And then on the outside radius here, we have sort of a similar thing going on. So I'm going to show you a path that we use to clean these up. Basically, we are going to use a pass with a 1/8 inch ball nose. So we're going to change our tool, and it's going to be able to go in here and just smooth some of these radiuses out. It's not going to make them perfectly as modeled, but it's a pretty easy way to be able to do all these more complicated profiles without having to do a whole bunch of tool changes. And it will work on an inside radius or an outside radius or any other interesting geometry you kind of have in the piece. As you can see here, we kind of have a combination of both going on. So that pass is my personal favorite. It is the scallop pass right up here. So we're going to click that, and our scallop window is going to pop up. And I'm going to want to change this tool as mentioned. So we're going to start by selecting the tool. And under our inventory, we still just have that 1/4 inch flat end mill. So we're going to add one more tool. I'm going to go back to the Fusion 360 library down here, and I'm going to look for an 1/8 inch ball nose. Just going to use kind of whatever they have. So here we go. We have an 1/8 inch end mill. So same as before, I'm going to right click that, copy tool. I'm going to go back to our library, and I'm going to paste it. So now we have this 1/8 inch ball nose. I'm not going to change any of the tool specific data. I'm just going to use it as is. So I'm going to go select. And now I've got my 1/8 inch ball nose loaded as my tool. So first of all, I'm going to show you what this scallop operation looks like. So I'm not going to change anything. I'm just going to click OK, and I'm going to let it generate the code for this operation. So it will look something like this. And basically it's running a pattern all over the surface of the part, and it's going to mill the faces, the depressions, any interesting geometry. And because we're using a ball nose end mill, we're not going to end up with those sharp edges. We're just going to end up with these little inconceivable cusps, and the tighter our pattern is on the tool step over, the finer the resolution we can achieve. This works really good for creating intricate detail without too many tool changes or a lot of intricate tools. So this looks really good, but I am going to show you how I can get it to avoid certain surfaces. So because these top surfaces have been milled with a flat end mill, I might not want my ball nose running across these and leaving a bunch of cusps. I might want this perfectly flat. So I'm going to show you how you can remove certain faces from this operation. So we're going to go back to the tool. I'm going to right click on it and go edit. So we're seeing a lot of these features pop up over and over again. So our first tab is feeds and speeds. Our next tab has some geometries. We've been over some of that. What I'm specifically looking for is under this tab, and it is the avoid touch surfaces. So if I click that, I can actually get this operation to avoid certain areas and surfaces. So if I want these surfaces to be left alone, I'm just going to go and select them. If there's any others I don't want it to touch, if it was going to go down here, I might want to touch those. Other than that, I want to make sure that I'm leaving the surfaces that still need to be milled out. You may have remembered from the roughing pass that there's quite a bit of work that has to go on in here. These surfaces are not going to be mating surfaces, so I don't mind if the ball nose runs over those. So now that I have selected those surfaces, I'm going to click OK. So now you can see how the operation has changed. It's avoiding the areas that we did not want it to touch, but it has still gone into all these depressions to clean up these radiuses, finish off some of the material removal that was not completed by the 2D adaptive pass. It's also followed these outside radiuses and kind of smoothed those out. It's even gone down into these chamfers and performed some work down there. So again, it's not going to be 100% as modeled, but it's a pretty easy way to get that part close to what you're looking for. So that's a pretty fun toolpath to play around with. It can apply itself to some pretty complex geometries. It could do circular faces. It could do complex angles. It can do these radiuses, obviously. It does a lot of work for a simple operation, and it can achieve a lot with just a single tool. These step overs can be adjusted to increase your resolution. You'll probably find that the cusping produced by the ball nose is almost imperceivable in the part when you take it off. You could also run this operation with a flat end mill if we were trying to eliminate this process down to using a singular tool, maybe not on this part, but a similar part. We could run the scallop operation with the same end mill we perform all the operations with. You're just going to end up with more perceivable stepping in here, but you can minimize that by changing the resolution. Nonetheless, it could be done. The last thing I'm going to show you is I'm going to go back to the scallop pass. I'm going to go to edit. We're familiar with all these tabs on some level now. Again, I'm not trying to get into too much information. If you do want to change the step over on those passes, you're going to go to this tab right here, and you're going to see step over down here. It's defaulting to 1/4 of a millimeter, so that's pretty small. If you wanted to reduce the amount of machine travel time, you might increase that. Or if you wanted to achieve a higher resolution, you might decrease that. Either way, that's where you'd edit it. But beyond that, we are done with that. Those are the 3 operations I wanted to show you. We didn't take this part all the way. Obviously, there's some holes and stuff in here that our other end mills couldn't get into. But I feel like it was a pretty good demonstration on the simple tool paths that we use all the time and how you can hammer through them without getting too bogged down in the details. So hopefully this was helpful. I'm going to do further videos on setting up tool libraries and maybe getting into some of the specifics of these individual operations. But hopefully that'll get you up and running without too much of a fuss and get you learning some of the options and parameters that you can tweak while you're running these tool paths. It takes time to learn all these features, and I find the best way to do it is just to start making some code first in Fusion, then translating it into your machine and just running some passes. You can learn your feeds and speeds and what works for you, your material, and your machine, and then start playing around with some of the other settings to try and get the results you're looking for. It really all comes with experience. There's only so much I can show you in the software. It's highly user dependent, and I think it's worth learning and playing around with some of those different options and parameters and exploring further what they can do and grow your skill set when it comes to generating the code. Now we have all 3 of our operations here. They're listed in the order in which they were created, and this is the sequence the machine will follow. So if you want to change any of this, you could select any one process. You can click it and drag it down or up in the queue, and it will change the order of operations. If Fusion needs to regenerate the code to make that new sequence work, it'll prompt you to do that. And this allows you to not worry about the order necessarily right off the bat. You can always make changes. We package ours in groups of the type of tool that's going to be used just to minimize our tool change. So because our adaptive and contour paths are using the same tool, we'll leave those together and then our scallop pass at the end. So before I sign off here, I'm just going to show you one last thing, and that's going to be how to post your code so you can run it in your machine. So to do that, you can go to your setup where all your tool paths are saved. You can right click and go post process, and it's going to bring up a window that allows you to post the process to an output folder, which will probably be a flash drive. You can name the file, you click post, and it will send that data to the flash drive and ready to run in your CNC. There is a limitation in the free version of Fusion. It will not let you post that entire setup if you have operations that involve a tool change. So because we're using 2 different tools here, it actually won't let us post that process as one line of code. We're going to have to post them individually based on tool. So I can actually select both these by selecting that one, holding shift, selecting the next one, right click and post, and I can post those 2 processes together because they're using the same flat end mill. And then I would have to post my scallop pass separately. So that's a bit of an irritating feature that they've incorporated, but they do that intentionally to try and get you to pay for it. It's not a big deal unless you have a whole ton of tool changes. But that should be the last step to get you actually running some code. So hopefully you found this helpful. Thanks for watching. I will make more videos, so be sure to subscribe.